Okay, now let's try a problem that deals with directions. So it says we have a simple cubic structure, and it's asking us what is the distance between the centers of adjacent atoms along this particular direction, the 1, 2, 0 direction. Simple cubic makes this really easy for us. Now, if you don't know what a simple cubic is, it simply means that I touch along the edges of my unit cell. So my box is perfectly touching all the centers of my atoms. Now, what is the 1, 2, 0 direction? Well, I can define this pretty much however I want. It doesn't matter too much. So 1 is the x direction, 2 is the y, 0 is the z. That's the third one. And so going like this would be the x, this would be the y, that is the z. So 1, 2, 0, if I were to draw it, would look something like this. As I know, I'm looking at it directly from the top right now because I'm only in that xy plane. So once again, this is the x now, that is the y. And so it's saying if I start here and I go 1 step down and then 2 steps over, I'm going this direction, when do I hit another atom in the center? Now, luckily for me, because it's a simple cubic, I hit one right there. And I went 2 steps over and 1 step over, 1 step down. And all the math here works out gloriously. So I know that I'm only 2 radiuses on this side, and I've got 1, 2, 3, 4 radiuses on this side, and it touches perfectly right there. I have to smack it straight in the center. I can't just like graze it for this to count. So I just use Pythagorean theorem and I'll have my answer. So let's see here. C squared is going to be equal to 2r squared plus 4r squared. So c squared is going to be equal to 4r squared plus 16r squared. C squared is equal to 20r squared. There we go. And so if I then solve, what I get is that c, or that distance between the two, would be equal to, making it look a little bit nice, 2r square root of 5. Boom. That is it. That wasn't bad at all. Not bad at all. So that's it for this one. I'll see you all next time. Bye-bye.